Hey, hi everyone. In this video, we will be talking about how Node validates a transaction. If you don't know what's a node, if you don't know what's the transaction is something you don't need to validate as of now. You need to worry as of now. Node is something we did have a talk in our last video. What is a node? We will get a bit hang of a node, and then we will understand what's the entire picture here and what's the validation. First of all, what's a transaction? Let's talk about what's a transaction. Transaction is something, let's say if you go to a bank, right? If you go to a bank and you say, hey, this is me. I have this bank account in your I have this account in your bank and I want to send 100 rupees to my friend. Let's say P1 is sending to P2 100 rupees. So P1 should have, I mean, P1 should have a bank account, first of all, enough amount. Let's say if I want to send 100 rupees, so the account should have minimum 100 rupees and more than that should work. And then the receiver's bank account should also be valid, and otherwise this transaction won't happen, right? So this is the work of a bank to make sure that this guy is genuine. This guy who is asking me to send money, let's say I sign a withdrawal amount or a check, the bank has to verify that this is the right owner who has requested the transaction. How do they do that? They do that with the help of the signature, right? We sign with the help of paper, with the help of a pen. That's signing that yes, I am the actual owner of this money and this account. And then that money gets checked and transferred to the receiver. This is nothing but same thing as here, it's transaction. What is node? In place of in our real life example, the place of bank in place of bank in Web3, or I would say in Bitcoin, this transaction thing, node takes care of this transaction. How does it do that? That's the point. First up, let's come to the point. As I just said, it checks sender is actual owner of the amount and account. Okay, whenever whoever is asking, who's the sender is whoever is saying that this is my account and this is the amount I have and this is the amount I want to send, checking that this is the actual sender or this is the actual owner of the amount and the account. Second thing, checking receiver's account number, or whatever you call receiver's account number, or something called, we will talk about this later, we won't get confused here. And the third thing is the account, the sender account has adequate money, right? This is something the node does in the transaction thing, and this is nothing but a transaction, right? I hope you got this. Now the thing is, how does from I mean, first we will talk about from where does node come into the picture, and then what does node do, right? So let's go here. We will talk about, so let's say you are on a platform, whatever platform you're using. Let's say you are using a wallet or whatever. That wallet or whatever you're using to send money has a server, right? So we will call it platform server, right? Platform server. What is this server? What does the server do? What does the server do? That's the main concern. The server does few things. The server creates an object. What object does this server create? This server creates an object that has these specified data. First, whoever is sending the money, sender's public key. Now, before talking about this, let's talk about, first of all, let's talk about what is public key and what is a private key. So, in consider consider here that in place of, let's say, bank, okay, and we will in web, okay, in place of, let's say this is in case of bank, and this is in case of Web3, or not Web3 actually, it's BTC, right? What happens? Bank, what do you have? You have your name, you have your bank account. Other things are not necessary. You have your bank account, right? And this bank account has money. And how do you take ownership of that bank account? You do this with the help of your fingerprint or signature, correct? In BTC, in this particular sense, whatever we are talking about, so sorry for this. In bank account thing, what we have is we have a, instead of this account number, I would say let's call it account number, right? In case of BTC, we have two keys. Please pay attention here. We have two keys, which is a private key and we have a public key. Or what I would say, don't worry about private key. Here we will say we have a public key, or you can also call it the wallet key, right? In place of this bank account, in BTC, we have this public key, and or you can also call it wallet key. Now, here in bank, you have fingerprint and signature to tell that yes, I am the actual owner of this amount and this account, right? In BTC, we have something called private key, right? I hope you got this. I hope you got this comparison here. So now that means if you want to tell, or whenever you are requesting a transaction, what do you need so that the node or whatever the entire process sends the money to the receiver? You need your private key, and that's why we say it's not your private key, it's not your amount, right? So you have to be sure that you don't share your private key. You can share your public key because public key is like bank account, sharing your bank account. That's perfectly fine. Anyone can't do anything until and unless you don't give your fingerprint or the signature, or in this case, your private key. It's totally fine. Yes. So whenever we will share the public key and the wallet key. This has, and so now the question comes that banks, there's a officer who sees that the fingerprint matches or the signature matches when you created an account, right? What happens in this case of this private key and a public key? To understand this, we will understand a concept called hashing and encryption. We did have a talk about hashing and encryption before, but I will give you very quick note of what does hashing says. If you don't want, if you already know this, you can move forward, right? What does hashing say? Hashing says that give me a text. Let's say I give a text, I give it a text, let's say hello, right? What does hashing say? Then give me a text and pass it through a function. Give me a text and pass it through a function or whatever. There's a logical black box. If you are a developer, then you definitely know what a function is. Function that uses a hashing algorithm. In our case, it is SHA 256. Okay, this is an algorithm that this function will use. What will happen is this function will definitely give us an output. Otherwise, what's the use of it? Correct. So it will give us something, an output like this. Correct. But two properties of hashing is the output is in hexadecimal. What is hexadecimal? If you're a developer, you know this. There are two things in this particular case, that once you create a hash, I'm talking about hash. Once you create a hash of a normal string, the string it gives you doesn't matter if here you are, instead of hello, you are just passing h, or let's say a string that is, let's say 200 characters long. The length of this output hash will always be constant. Doesn't matter if you are just passing h or an entire, let's say, paragraph of 200 words. the length here will be fixed, and that in our case here it is 64 length characters, or let us 64 characters or bytes. What is this? We will talk about this later, no need to worry, but you need to know that the length will always be constant. On the other hand, now we will be talking about what is encryption. Encryption says encryption. Encryption says that give me a text. Okay, give me a text. Then pass it through same. Pass it through a function, right? Pass it through a function. This function will have a logic. Okay, that is not dependent. That is defined. I would say that is defined by the def. Now, after this def, the output of this function will be again a string, or whatever it will be, mostly a string. And let's say here also we get like this, something like this. There won't be any space. I'm just giving an example. The difference between hashing and encryption is, to make this particular thing encryption, to make this encrypted. What is encryption? Nothing but changing a plain text to something very random, so that even if someone wants to understand what the actual text is, they won't be able to, right? So to make this encryption happen, which is changing this to this, we need something. We need with this logic, we need something called a private key, right? A private key. What is, just understand this. For encryption, I would write it up here. For encryption, we need a private key. And what is a private key? Private key is nothing but same as the fingerprint and signature. We will very shortly understand how this private key matches to this fingerprint and signature, and how does it caters the same thing in the bank here, right? So for encryption, you need private key. With the help of this private key, how does this private key look? This private key looks something like it is something like this only. Okay, like this. And this is not actually how it looks. It looks a lot different, but it is nothing but a string. Okay, this is a private key, and like let's say an API key. It is very important, right? So for encryption, you need private key, but in encryption or slash decryption, whatever you want to call it, array, decryption, what the difference here, one of the main difference here is, if you use if you don't know how to create a private or public key, it is very easy. You have to run a line of code, and the system will generate a pair. It will create a pair. What that pair will be? That pair will consist of one private key and one public key, right? Whenever you will create a private or a public key, it will always be generated in pair. That means this public key is a pair of this private key, and this private key is a pair of public key. You can't use any other created. Let's say you 2 times created a key pair, right? You can't merge the public key of another pair here. Okay, they have to be in pair. So what does it say? If you want to encrypt, then it uses the private key. Okay, but if you want to again go back and see what the original text was from this string, from this random string, what you can do, you can use the public key, which has to be, please take care of, which has to be the pair of this particular private key. How do we get pair? Whenever you generate a key, you get a pair only, right? I hope you got this. So in hashing, we go one way, we can't go back. In encryption, we can go forward with the help of private key, and we can go back to the original thing with the help of public key. And the length here is constant. Here, based on the algorithm, it can be constant or it can vary. Okay, I hope you understand difference between here. Now we also will understand how fingerprint is equal to private key. Coming back here, so what we get here is, if you now know, okay, sender's public key. What do you mean by public key? Public key is nothing but the bank account number which is available all over the world, that this person has this bank account. The receiver's bank account, which is receiver's public key. So now in from now I will use public key in place of bank account, in place of saying bank account. The last, the not last, the next thing is transaction amount, how much money you need to transfer. Transaction fees, no need, I don't think there is an need of explanation here. Then it takes the timestamp when the amount was transferred, and it takes something very important thing. It creates, the platform server creates this, okay? The platform server creates this object which has something at the end which is really important, which is signed message. I think all of other things are now clear to you, but what is this signed message? We will understand that first. Okay, and this, and encrypt, and the knowledge of encryption and decryption will help you to understand how this signed message is created. As I said, platform server creates this signed message. So how does it create? It is created by this process. We will go here, we will see how this signed message is created. What happens here is, first of all, I will give you a text explanation here. I hope you understand. Whenever a string hash string is encrypted with the help of private key, it is a signed message. Now understand, if you see, compare this signed thing, signed, let's say, what does it mean? That the sender, okay, the sender is signing this hash. What is this hash? The hash is nothing, the hash is nothing but the random number that got created here with the help of this hello string, right? This hello string. So just give me a moment. Yeah. Now, what is this message? What is this string? What is this hello string? If you see, we create this hash with this, with the help of some input, right? So that means to create a hash we need an input. I will tell you how this signed message is created. Now we will talk about how this signed message is created. First, the platform server takes three things. It has all the necessary object available, all the data available. It takes the three things. What it takes these three data. It takes these three data, which is sender's public bank account, public key, receiver's bank account, public key, and transaction amount. And what does it do? It takes the string combination of these three and put it through this hash function. And what we get, I hope you understand that as of now. What we get is, we put it through a hash function which is SHA-256 algorithm. That function uses SHA-256 algorithm, and we get a string. Okay, let's say okay, let me do this. Let's say we get a string. Okay, and we get this string. Now, on putting this thing, a combination of all three as a string to this hash function, we get this string. This is nothing but a hash, right? Now, as I said, whenever a hashed string is encrypted with the help of private key of a sign, it is a signed message. That means this message, now in terms of bank, you are basic, this is a check. Let's say this is a check, and now the actual sender, the authorized person who is actually sending this data, this is nothing but a data, nothing but a check details. The sender is nothing. Now the sender has to sign and say, yes, I am the one who is sending the money. How do they do that? is nothing but by encrypting with the help of their private key. This private key is only available to the sender, the actual owner, and that's why we say don't share your private key to anyone. So what do they do? They take this and they do encryption with sender private key. Who does this? Is it available on the internet? No. The platform does this. The platform has the private key of the sender. Most probably they don't, but yeah, this is what happened. Now encryption happens, and what do we get? What do we get? Whenever encryption happens, okay, I'm so sorry here. Whenever encryption happens, what do we get? We get a string which looks totally different, right? Which doesn't look like this. It has to look totally different. And this is nothing but a signed message. Okay, I hope now. And this signed message is included here. Cool. Now, when the platform server gets this data, and we just talked about how a signed message is created, this data is ready. What does it do? This server of the platform is most probably, not most probably, I would say always connected to the Bitcoin network. Okay, this is connected to the Bitcoin network through a software. Connected through a software. Now, this Bitcoin network, this is one element which is connected to the Bitcoin network, right? There are more such elements. One of the elements, one of the element is also is something that I mean, I'm not that doesn't look like a circle, but yeah, I'm just giving you a hold of it. These are called nodes. Okay, one more thing which are connected to Bitcoin network is called nodes. How does this connection, this server connection to this Bitcoin network and connection of these particular system are different, and these thing on the right are called nodes and these thing on the left are called platform servers? It is because they register themselves as node, they register themselves as a user, a platform user, right? I hope you got it. And how are they connected? Same, might be a bit different, yeah, but software, they use the software. Okay, and these nodes are not only directly connected to the Bitcoin network, they are also connected to each other. Okay, they are also connected to each other like this. Not only one, let's say this is also connected to this is connected to this. There's a mesh network. And you can't define how anyone is connected. I mean, it could be like this directly or whatever. I hope you got. And these all things here are what are they called? They are called nodes, because they register themselves on the Bitcoin network as nodes, right? I hope you got this. I will bring this thoda sa ऐसे. ठीक है? They register themselves and they call themselves node. Let's say do this. Mm, yeah, yeah, good, looks good. So now these are called nodes, and these nodes are nothing but they do work of what? They do work of a bank. And what does bank do? The bank does all the three things. Now we got the request. The platform server has created a request. They have an object ready. The money is ready to be sent. The check has been made, and it has something. It has the data like on the check, and it also has a signature, which is signed message. And we know how a signed message is created. Now we will talk about how node, or in our banking world, how does a bank validates that yes, the amount, the sender is the actual owner with the help of something called the signed message, which is nothing but a signature. It is checking, it also checks the receiver's account is correct or not, and then it checks that the sender has enough money or not. So let's start with node. How does a node work? I will keep it side by side, okay? Because this is something the node does, and it will be very helpful to compare this part to this part. Basically, we will start with here. Let's start with here, right? First thing what the node does is, see, as we talked here, being a bank or the actual authorizing thing, they checks if the sender is the actual owner. And how will they do? How does the bank officer does? They check the sign, the signature or the fingerprint. And this is what we will start with. Checking the transaction has been requested by the actual owner or not. Okay. How do they do in banking world? They do by checking the signature. And we have this signed message. So if you remember, not know, if you remember, how was the signed message created? Once they took all the three data, they created a hash, they got the hash, and then they encrypted this hash with the help of sender's private key. That means the sender signed this message. Now the bank officer will get, what is the bank officer getting? The bank officer is getting the entire check, which is nothing but the signed message. The bank officer will come here. Okay, the bank officer will come here and take this signed check. Okay, the bank officer will come and take this signed check here, so I will point it up here. Cool. Now after getting this signed check, what will he do? He will check with the actual sign, actual previous sign. But as I said, private key, it was signed with the help of private key. Is private key available to the internet? No. So, but there's a pair of this private key. If you do remember, encryption is done with the help of private key, but decryption is done with the help of public key. So, it will use, I'll copy the string here. It will use the, I would say, it will do the decryption, which is opposite of encryption. It will do the decryption with the help of sender's public key, because decryption is done with the help of what? Public key here, public key. So it will use the sender's public key. The node has the public key, sender's public key. How does it has? Because this was sent to the Bitcoin network from the platform here, sender's public key. It uses this. And what's the guess? When this process which went down, when we will do reverse engineering, what will we get? We will get this, correct? So we go here and we get this, right? Now, if you do remember, what was the first process here? It is hash. But hashing can go only one way. We can't go back. That means from here, from here, we can't reverse engineer back and get the all three data and verify, right? But what we can do is take all three data, because we already have all three data available, which has been sent from the platform server, and create a hash. This algorithm is available free for all over the internet. And what will it get? It will get this. So we will take these three things. I will write it up here so that you get a good hang of it. We will take these three things, which has been sent from the platform to the node. What I will also do is create a very this and this. This is happening on the node. Okay, this is happening on a totally different machine. Don't confuse it with here. This is happening on a node. This data was sent from the platform server to here. It decrypted, and now it takes all the three data, and what will it do? It will create a hash out of it. Correct? It will create a hash out of it, and this hash will nothing but create the same this particular data, not hash, this particular data. Let me select it. This particular data, if all the three data here and all the three data here, they are exactly same, then the hash that will create will be exactly same. This is what we talked about. This is property of hashing. Then what will happen? They will compare it, equate both of this data. if both of this data is equal to this data, and this data is equal, that means the sender is the actual one. The sender is the actual one who did sign this message. Why? Because with the help of sender's public key, we did decrypt and we got a hash. And with the help of sender's public key, receiver's public key, and the transaction amount, we did create a hash and it was same. And hence, this thing is nothing but first stage of validation. That means yes, the bank, the we what did we check here? We check that yes, the transaction has been requested by the actual owner, which is the sender. Now I hope you understand why fingerprint and private key is equivalent, because fingerprint is used by the sender or the actual owner. Here private key is used. Then the bank officer, in this case the node, uses the public key, which is nothing but a bank officer checks that hey, the public, I'm using the pair public key and I'm getting the same data. That means it is valid. That means the owner is right. The correct owner has requested the transfer. Now this is just the first step, right? This is just the first step. I would do this 1.1, right? These two are checked. Now what will happen? Second step is the owner is right. Now they will check the receiver's account number, which is account number is equal to what? Account number is equal to the public key. So how do they do that? It is very simple. We will say checking public receiver and sender public, or what you call wallet key. How do they do that? This is very simple. Bitcoin, whenever it creates a public key or the whatever or the wallet key, this thing is created with the help of already bit set of patterns. They do that pattern check, and then they see if the particular private key is getting matched to some of the pattern or not. If any one of the pattern matches, then that's valid. Okay, this is not very let's say technical here. After this, that means we came to the second step, where we did check that yes, the account owner is correct. The correct owner has requested a transaction. The account number are correct. Now we will go to the last, which is the sender account has enough money or not. So how do they do that? The node, which is currently the machine we are inside, the node checks UTXO, a new jargon, which is unspent transaction. I'm writing it very slow, which is unspent. Just give me a moment. Yeah, it is unspent transaction outputs, or in simple words, unspent BTC. Unspent BTC, right? What does this mean? And what is this UTXO, or this? This is considered this to be as a sort of database, okay? Not centralized, but a database that keep tracks of how much money a particular public address or a wallet has, okay? Same as a bank account transaction or passbook that keep tracks of, hey, this person has this much of money left, this much of money left. How does this UTXO does that? This is very interesting, and we will get back to this later. This is part of a block. What is a block? We will also get to that. So once, if let's say the money is valid, so now if all the three process go through, then it says yay, validation done. And this is how a node validates a transaction, right? I hope you got it. So this was the video about. In the next video, we might be talking about what is UTXO, and then we will move forward, continuation of how a particular transaction is done in Bitcoin, and how it is the transaction is added to the Bitcoin network or the blockchain. Cool. Yeah. Thank you so much.